My name is Gupta, and I'll be giving the presentation on Modaclouds Decision Support System in cloud service selection. So this is more a business perspective as compared to the other presentations that I've seen in the session. The idea is that we in CA Labs Barcelona is the R&D department of CA Technologies, and here we are participating in a European Union project called Modaclouds, and out of this participation we have been able to develop a technology for decision support system, essentially applying to cloud service selection. But the development of this technology has been fairly agile and quite adaptive to different scenarios. And the bigger objective of this session is essentially to start a brainstorming with the LDBC community and the decision support system technology that we come up with, and see the coherence and overlapping parts there. So this is the outline that I'm going to walk you through. Fairly straightforward. Basically, the idea is to be able to bring together that what is the need and motivation of this kind of system in a cloud service selection scenario, followed by the overview and the key features. And then I encourage that we have some kind of brainstorming in order to see a compliance between these two. So this is what we have been talking about. A decision support system is essentially a recommendation system that we have designed organically in CA Labs, which deals with being able to provide a platform to multiple stakeholders in any enterprise to be able to select the cloud services meeting their requirements. And when we say meeting their requirements, the requirements could be quite orthogonal in nature. So you need to find a common platform to bring it all together, being able to assess them under a same dimensions or a same benchmark, and being able to suggest what is appropriate to a naive user specification of requirements. And that's what the DSS that has been developed provides. On top of it, as the graph database community is evolving, I think it's a very interesting phase to be able to see how what are the different characteristics or parameterization of graph databases, which are which are maturing, so on and so forth, and how this DSS technology can be brought together with this community and be able to come up with a recommendation system useful for the enterprise who intend to adapt this kind of system. So let me just walk you through about exactly what motivated the decision support system. So when I'm as a user, when I'm going to pick up cloud services, I have multiple dimensions of comparison of these cloud services, and these dimensions can be legal, they can be technological, they can be organizational. I want to make sure that when I take a cloud service, when I take an EAS or a PaaS or a SaaS, I make sure that my data is being stored at a location which is under the jurisdiction I'm fine with. I make sure that the technological requirements are met, auto-scaling is there, horizontal, vertical. I make sure that the support provided by the cloud services is meeting my requirement, meaning to say it's providing me a 24/7 support, it's providing me support in multiple languages. So these are the various factors which come into play together when I'm trying to select a cloud service. And on top of it, we know that the cloud services which are there in the market are growing, and not only growing, but they are quite diverse in presenting what they are providing. So there's quite a mismatch between what we understand and how they translate their provisions. And it's quite necessary to have an unbiased system which is able to take care of all of these together. On top of it, even after I take infrastructure as a service or I take platform as a service, if I'm selecting any of them, it's fairly important for a user to be able to have the flexibility to be able to select the services from different providers or different vendors because they are there available in the market. So on top of the selection criteria, I also have to take care of the interoperability issues among the different providers. So that brings us to the multi-cloud environment, which decision support system essentially aims at. And multi-cloud environment come up with multiple restrictions leading to interoperability or ease of migration out of a service. You should not be vendor logged in a service. On top of that, once as a customer, if I'm able to make my choice with all of these together, I want to make sure that my selection is making the requirements which I have in 3 premier dimensions, and that's risk, cost, and quality. This is what we have been able to analyze through quite an in-depth business analysis. And therefore, there is a very clear and very important requirement, at least in the cloud service scenario at the moment in the market, to be able to provide a decision or a recommendation system to the users before they go the cloud service shopping. Therefore, a broad overview of what the technology CA Labs developed as a part of decision support system, it essentially is able to take in from the end user the multiple, I'll walk you through the technological terms that we are using here, but multiple assets, multiple risks that those assets are facing, and essentially the requirements which the user wants from the cloud services. And this kind of decision support system, after taking the entry, is able to provide to the user what all are the interesting cloud services which are meeting the requirements which I have placed in the first step. Following that, the user is able to select that, hey, out of all these lists that you provide, I'm able to, the one which is most useful for me is this one, and I'm able to set you, the DSS is able to provide you, as a part of Modaclouds, the deployment specifications in order to use that set of service. Well, the broad overview of DSS covers it all, but there are a few important features of the DSS, the key features, which essentially are quite independent of just the broad cloud service selection and are quite relevant for graph databases community. And I'll walk you through these features. The first is, from an enterprise point of view, it's fairly important that the decision making is not really entitled in the hands of a single person, and that's usually the case. So you have multiple stakeholders within an enterprise who are specifying their needs within a cloud service selection problem. So I'm looking at a business decision maker who has his own requirements from a cloud during cloudification of a particular asset. Similarly, I have a technical person who has his own requirements within the same enterprise. So it's important that when you're selecting a cloud service, you're providing a platform for all these stakeholders to come together and participate. Therefore, the DSS, it provides a mechanism and multiple tools which are allowing and promoting this kind of participation of multiple actors in the decision-making process. And even within this multiple actors, why is the participation important is when we are able to see that the actors have fairly orthogonal requirements. So as a business analyst, I'm more concerned whether the customer loyalty is maintained if I'm cloudifying an asset or not, whether my sales rate are not being disrupted if I'm doing this kind of vendor shopping or not, and so on and so forth. However, as a technical person, I'm more concerned about, is the data integrity being maintained? Is the data privacy being taken care of? So as technical perspective, they are quite different, and although one can be translated to another, but it's important to have these prospects together. What DSS does is it allows these actors to provide their assets or what is important for them, and it assimilates them and is able to analyze what are the risks which are associated with these assets. So therefore, our methodology in DSS essentially allows this multiple participation and then allows a risk-based assessment of these assets of multiple actors. So now I'm talking about a risk analysis method which we have implemented within the DSS. It talks about being able to identify what all are the susceptibilities that the assets which the actors want to protect, and what are the properties that the cloud providers should have in order to protect these assets from the risk. So therefore, it's a quite a concrete methodology based on the risk analysis, which allows us to translate a naive user requirement into the properties of the cloud services. So the idea over here is essentially being able to identify the dimensions of comparison of cloud services in a fashion which is useful for the end user. And this seems to be quite an interesting and quite a docile kind of thing, because what is important for a particular set of users keeps on evolving as the market is changing. So this is something which requires quite a lot of evolution, and it's fairly the time to do that in the way the cloud service market is growing. And on top of it, as I said, that apart from translation of the requirements through a risk-based analysis, other feature which DSS holds and which is fairly important is the multi-cloud environment. That means if I'm taking a service from one cloud provider and another service from another cloud provider, I need to make sure that from my perspective, these two are working together in coherence. I need to make sure they interoperate, they're able to communicate, and the vendors are giving me the SLAs which are complying to all of these. Therefore, to take care of the multi-cloud environment is essentially this is one of the premier DSS which is actually doing this kind of thing. It's important because even in the case of, as we have been, as the community evolves and as we promote new vendors to come up, taking care of multi-cloud environment is essentially a cornerstone of development, of at least giving more flexibility to the users to select the cloud services. Now, essentially, for the multi-cloud environment, as I've been talking, there are some specific problems which come up, and they relate to vendor lock-in, as in if I am an Amazon user and if I take all the services from Amazon and I need to make sure that I have to migrate one service out of Amazon, it might be very difficult for me. Therefore, I should not be stuck in a situation relating to vendor lock-in. And multi-cloud environment is the platform which is actually providing me an opportunity to be able to see this problem and analyze it. So, furthermore, security becomes quite important in this kind of environment, just for the simple fact that if there's a close coordination between two different vendors, what data is visible to one part of the service and what data is visible to the other part of the service brings an immense amount of SLA issues, at least with the big enterprises. Forensic evidence, of course, if one particular vendor is able to assess, is able to blame the other vendor that this thing went wrong, we need to have a very, very concrete forensic mechanism in place, and that plays an important role pertaining to multi-cloud environment, essentially. Cost unpredictability, of course, if we are looking at different vendors working together, we need to make sure that the cost changes in one service does not really affect my specifications of the other service, and therefore I don't make the whole model so unpredictable that I can't assess my financial statement for the next year. And then you need to make sure that the vendors are quite encouraged in order to participate in this kind of multi-cloud environment itself, giving flexibility to the users. And again, lack of negotiation that essentially comes from the interest of the CSPs to be able to provide their services in multi-cloud environment. So these are the main challenges in the multi-cloud environment, which the decision support system is actually addressing by providing the user recommendation regarding the multi-clouds in general, therefore making sure that the challenges are quite, to an extent, answered. The other important feature that we have from this technology that we developed is that in order to assess the different cloud services, even after the user is able to specify us that these are the properties I desire out of the cloud services, I need to be able to assimilate the data from the cloud services. So I need to be able to get the different dimensions from the vendors such that I'm able to assess on a paradigm of, say, some legal issues or what are the certifications which the providers have. I need to have the data public. And this kind of automatic data gathering mechanism is in itself quite a task, and it's actually one of the biggest challenges which we have from designing a recommendation system. And in DSS we use different, I'll not go into the technical details of it, but we use different mechanisms so that we are able to process the flat files and the databases in order to extract the data on the basis of a number of dimensions that come out of the risk analysis based approach. The other important feature that we have is also progressive learning, meaning to say that as the usage of a recommendation system increases, based on the other users' choices, the recommendation system is allowing the new users to make the right choices based on whatever has been selected by the other user. Therefore, there's a sort of a very concrete mechanism in place which allows you to make the DSS mature and more efficient, provide better recommendations over the time as it evolves further. So this is one of the very interesting features, and it also ensures for this kind of technology that the sustainability of this technology is maintained over a period of time. So to sum up, we have developed a decision support system prototype which is already online, and here are some screenshots of the same, and it's been organically developed by CA Labs, and the technology is online, and I encourage you to play aloud with it. It's on dss.modaclouds.eu. This modaclouds.eu is the domain name of the project that we have worked upon. The project is about to reach its end, and the tools are quite mature to be played with. And well, everything is open source around here, so you have the repository in GitHub, and the documentation is available on the website. So I encourage that this particular tool is quite interesting if you're able to bring together, at least to an extent, if you're able to bring together the business perspective and legal perspective and technological perspective, and even to make simple choice. I mean, to play with simple examples. It's a nice way to go ahead with it. So the main idea of this whole talk we have is essentially to encourage an open discussion between this particular community and what is possible out of extraction of decision support system, as I said. And we have quite a few questions, which maybe, I mean, I think it's already out there to answer probably part of it. But we had some questions that if we are to make a decision support system for cloud graph database selection or benchmarking such thing, what are the different characteristics that are actually going to define it? What are the characteristics, or what are the properties which allow you to say that this particular technology is good enough, at least from graph database perspective, and which is not? And what are the criteria of selection? Another thing, who is going to make a decision in the industry once graph databases are increasingly being used by the community? Which are the decision makers which are making the decisions, and what are their perspectives? Are they taking into account all the perspectives which are essentially associated with the graph database itself, or this decision is even minutely affecting the business perspective and technical perspective separately or not? Then we have questions like how are multiple vendors going to work together in case the graph databases, the technology gets matured? Will it be able to have interoperability issues, or are they worth addressing, or there's no problem around it, things like that. The other thing is, if one important problem we faced, at least with the cloud service selections in general, is the data gathering. And is this kind of characteristic definition or specification definition public? Is it possible to gather it? And will there be a decision support system which is able to take care of the data gathering itself as well, and is able to recommend which is the best graph database to pertain to the particular demands of the industry? So these are some open discussion questions, which some of the answers might be around here. And that's essentially it. And I encourage some kind of questions if any. Yeah.
Thank you very much. So, Peter, you may consider getting connected as we're getting questions to Smriti. So, any questions?
I do have a question. So, thank you very much for the talk. I think that cloud environments are going to be more and more, as they are actually, obvious in technology environments. So I think that this would be a very interesting. Give me the other one. A very interesting topic, at least for discussion within the LDBC Council, on how to address the need for some type of benchmark that does not include only performance issues, but also it does include cost, as you were saying, and these SLAs that may be very, very important. So I think that whether or not CA becomes a member of the LDBC Council, I think that this is an important topic, at least to discuss within. And I wonder if you have some documentation that could be used, could be read, could be, I understand that you pointed us to this type of documentation.
Yeah. Essentially, yes. I mean, as I said, the whole technology is open source. So in GitHub, we have the wiki, which actually redirects you to the entire documentation of the paradigms which are used, which exactly what you say, that we can have in LDBC the different dimensions of comparison, and that dimension, how we are collecting it, how we are quantifying the dimension, or how we are saying that if one provider is providing a certain cost for a certain entity, how is it comparable to the other provider? Those kind of questions are quite crucial and critical, at least for decision support systems. So yeah, GitHub provides you a wiki link for that.
Okay, do we have other questions? Okay, thank you very much once again.
Thank you.